Welcome to the class. In this class, we will discuss about the solar system. First, we will talk about universe. What is the universe? So, universe, what is the limitless expanse that you can see around you? So, universe will contain galaxies. How many galaxies? If one will ask, 100 to 400 billion. And each galaxy will have 100 to 400 billion stars. And we know stars will have again planets. For example, if we take our star Sun, will have planets, 8 planets. So, study of the universe is called cosmology. Planets revolve around the sun in the elliptical orbit that you remember. And the size of solar system you remember 10 power 5 AU. AU means astronomical unit. Astronomical unit. This is 150 million kilometers. In solar system, mass of sun is 99.86%. In rest 0.14, 71% again Jupiter. So this you remember 99.86%. And sun mainly compose 71% hydrogen. 71% hydrogen. We know in sun there is nuclear fusion reaction is happening where hydrogen is getting converted into helium, releasing lots of energy. Diameter of the universe is 93 billion light years. 93 billion light years. And there are some theories regarding origin of universe. Steady state theory given by Fred Hoyle. And other proponents also there, Hermann Bondi and Thomas Gold. Pulsating theory. It is given by Arthur Eddington and it is also another proponent, Alan Sundes. It is also called oscillating universe theory. Pulsating universe theory means it says universe expands and contracts in cyclical manner. Universe expands and contracts in cyclical manner. That is pulsating theory. Whereas steady state theory means the universe is constant. Okay, universe presently how it was like that and it will be like that. That is steady state theory. Pulsating theory, universe will expand and it will contract. For example, now universe is in expansion stage. And then Big Bang theory, proposed by Georges Lemaitre, very important. He proposed it in 1927. Big Bang theory says 13.7 million years ago. 13.7 million. This is the universe age, you can say. Universe age, 13.7. 13.7, there is singularity, means there is a infinite means small, infinite density, infinite small size. One singularity was existing and there was cosmic explosion happened. And then space, huge expansion of the space has been created, that too within a fraction of the second. And then all present, you can say masses, all that gaseous clouds, everything formed, stars, galaxies, everything formed. So if you remember 1929, Hubble has given the redshift movement of the galaxies. Redshift movement means here he observed that all galaxies and stars are moving away from us. Okay, when we see they are moving away from us. At the same time, they are moving away among each other also. That is what redshift movement. This is proof that universe is expanding. He given this one in 1929. So the Big Bang theory, that is universe is expanding, given by Georges Lemaitre even before that Big Bang theory, 1927 Big Bang theory given. Then there is one more thing, cosmic microwave background radiation. This is given by Ernest Penzias and Robert Wilson, who got Nobel Prize for that invention or discovery. Then Fred Hoyle. Fred Hoyle given one is steady state theory, steady state theory. Fred Hoyle, but he also criticized the Big Bang, that expansion, cosmic explosion, that universe expansion theory, we say. Big Bang theory is also called universe expansion theory. So he criticized the universe expansion theory given by Georges Lemaitre, and he coined the term Big Bang. So if anyone asks who coined the term Big Bang, Fred Hoyle. Fred Hoyle is coined the term Big Bang. Fred Hoyle. Next, the earliest stage of the Big Bang is the Planck epoch. This is, you remember, just a period. And then unification epoch and electroweak epoch are coming. Then first molecule formed after the Big Bang is helium hydride. Helium hydride. This ionized hydrogen means H plus and He. Neutral helium combined and form helium hydride. Next, the most abundant element in the universe is hydrogen. Very important bit. Almost 3/4 of the universe elemental gas. Next, you remember lambda CDM model. This is evolution of the universe related model. Then cosmic inflation was proposed by Alan Guth. Origin evolution of the solar system. There is catastrophic theory. It says there were two stars. Okay, binary star system. Two stars. Then when this star, one big star was moving around, some of the mass has been pulled towards the sun. Then these mass attracted has been formed as the planets. So if you take present sun like this, it is formed. That is the catastrophic theory. Some catastrophe has happened, and that's why solar system has emerged. But there is evolutionary theory like nebular hypothesis. Evolutionary theory is nebular hypothesis. This is given by Laplace. Very important. It says that there is pre-existing nebula. What is nebula? It is a cloud of dust and gas. Then a formation of the flat disk is happened. So first some nebula, some gas dust will be there. Then some disk kind of thing has happened. Some disk kind of thing has happened. Then ejection of rings of matter. In this matter has been ejected, and this matter has been condensed, and then the solar system, present solar system, has been formed. That is condensation to form. That is nebular hypothesis given by Laplace. That is evolutionary theory. Evolutionary means gradually the solar system has formed, not suddenly. Okay, like given in catastrophic theory. Then evolution of Earth, if you see, evolution of interior, we have to see. Evolution of the atmosphere and hydrosphere, we have to see. Evolution of interior, if you see, there is initially a very hot volatile condition of the earth was there. Volcanic eruptions, lava flows, everything was there. There was a lot of carbon dioxide, everything. Then density separation is lighter materials will be separated and denser materials will be separated. Then condensation, the contraction of the earth. Maybe earth, you say this much bigger. It will be condensed means it will become small. Then differentiation means now denser materials will come to the center and lighter materials will go away. So that is like if you see the center, you have nickel, iron. These are denser materials. These are in core of the earth. And whereas if you see the crust, you see silicon, aluminum. We say Cl. Cl in crust we will have Cl. In core we have Fe. Fe means iron. Then evolution of atmosphere. Early atmosphere was we have only light gases like hydrogen, helium. Because of solar winds, this early atmosphere has gone. Now then degassing will happen. Means when earth is lava, everything is coming. Then CO2, etc. Okay, CO2, sulfur, all these gases are coming from interior of the earth, and these are coming into the atmosphere. Continuous volcanic eruptions were there. Because of that, what happened? CO2, everything has been released. And later water vapor is also coming from volcanic eruptions. This water vapor is turning into rain, you can say, and over million and millions of years this rain is been coming, And finally the earth will slowly will cool down, and slowly the oceans will form because of that. Then Luca, last universal common ancestor, will begin to emerge. Then blue green algae, Vijay means blue green algae, blue green algae will born. Then slowly with that atmosphere, in the atmosphere oxygen will begin to come. This is we call great oxygenation event. That is not important. Next, come to galaxy. What is galaxy? Means a group of stars. Is simple definition. Group of stars is galaxy. We have Milky Way galaxy. This is our galaxy. Means our solar system is present in Milky Way galaxy. In ancient India, people used to believe that a river, light flowing in the form of river in the sky. So they called it as Akash Ganga. Our solar system is present in Milky Way galaxy. There are Magellanic clouds, two irregular dwarf galaxies. They are satellite galaxies of Milky Way. They are visible only in the southern hemisphere. The Milky Way is approximately 1 lakh light years in diameter. And if you see our Milky Way also, we have center. There is Milky Way for center. That center is 26,000 light years. Our solar system is 26,000 light years from that center of the Milky Way galaxy. And it takes almost 250 million years for the sun to give one revolution. Okay. For example, you take the sun. This is a Milky Way galaxy center. You can say this is center. To give one revolution, it will take 250 million years. So remember Milky Way galaxy. This is called Akashaganga. And Magellanic clouds are satellites for that, and we can see from southern hemisphere Magellanic clouds. Diameter of Milky Way galaxy 1 lakh light years, and sun will take almost 250 million years to give one revolution around the center of the Milky Way galaxy. Then Andromeda galaxy, it is our nearest galaxy. After if you take Milky Way to that which is nearest means Andromeda galaxy. It is also called Messier 31 M31, Messier 31 M31 or NGC 244. It is closest spiral galaxy, as I told now. It is 2.5 million light years away. This is important. 2.5 million light years away. It is called barred spiral galaxy. It is spiral galaxy. Spiral means like this it will go. Then classification of galaxy. The main classification is given by Edwin Hubble. He given four main types: elliptical, spiral, barred spiral, and irregular. Barred spiral. For example, our Milky Way galaxy is barred spiral galaxy. Then spiral galaxy, lenticular galaxy, elliptic galaxy. This is the other classification. There is one disc shaped galaxy. Disc shaped means as disc. Okay. For example, if you see CD, it is disc like CD, like that. It is example spiral lenticular lens shaped. Then spiral galaxy we know. Example you remember Milky Way galaxy, where we have spiral arms, have central bulge. Okay, then lenticular also disc shaped galaxy here also, but without prominent spiral arm. Spiral galaxy there will be spiral arm. Lenticular no spiral arm. Elliptical means this is not not flat disc shaped galaxy. This is almost like spheroid or spear kind of thing, elongated spear kind of thing. That is elliptic galaxy. It has no gas or dust, so no star formation is not possible. We will see life cycle of the star, so then you will understand. They're most elliptic or most massive galaxies. Elliptic are most massive galaxies. So galaxy, it is simply group of stars. Milky Way galaxy, solar system is present. Then Andromeda galaxy, nearest galaxy. Then you come to constellation. Constellation means it is a pattern. You see, you take some stars, you join them in some diagram. That is simply constellation, you can say. One well-known constellation is Ursa Major, called a Big Bear. Within Ursa Major, there is Saptarishi, seven bright stars. We call Saptarishi, seven sages, Saptarishi. In ancient times, people used pole star from northern hemisphere. You can see that pole star is used for the navigation purpose. Okay, it will remain stationary. Pole star is the same position will be in the sky, and with the help of Saptarshi, we can recognize the pole star. And with the recognized pole star, it is also called North Star. So we can determine the directions. Now we have compass everything. Okay, even Google Map we have. But that time people mainly depend on the pole star or North Star. We also call this as Polaris. So Polaris or North Star or Pole Star. Same name. And there are 88 constellations recognized by the International Astronomical Union. 88 constellations. Some constellation names: constellation Orion, meaning under; constellation Canis Major, dog; constellation Taurus, bull. If you take Orion constellation, brightest star is Rigel. Overall brightest star in the sky is the Sirius, which is the star in the constellation Canis Major. That is dog. So Sirius is also called a dog star. Dog star. Now, if you see NCRT, there is given Big Dipper, Little Dipper, like that. Big Dipper means it is also called a plough in UK. Big Dipper is the USA, Canada. They call Big Dipper. It is nothing but Ursa Major. Within Ursa Major, there is Big Dipper. It is nothing but Saptarishi. So Big Dipper, plough, Saptarishi are same meaning. They all lie in Ursa Major, Big Bear constellation. Ursa Major is the constellation. There is Little Dipper. This lies in the constellation of Ursa Minor. Ursa Minor. The pole star or Polaris is part of the Little Dipper. The pole star, I already told, it is stationary. It will not move. It is stationary. In India, we call the pole star as a Dhruv Tara. Dhruv Tara. One more point: pole star is not visible from the southern hemisphere of the earth. Okay, I already told, from it is called North Star. So from northern hemisphere you can see it, but from southern hemisphere it is not visible. Okay, this earth is bulge, no? So we cannot see that. There is zodiac constellation. Remember, it is set of 12 constellations. Then 5 largest constellations in decreasing order. Hydra is the largest constellation. Then Virgo constellation, Ursa Major constellation, Cetus, and Hercules constellation. There is also one Indus constellation in the southern sky. Now you come to stars. We know stars are very big, very massive, very hot. They releasing huge energy. For example, Earth getting all energy from the sun only. So they are made up of huge gas. There is nuclear fusion. Nuclear fusion reaction is going on in that. What is nuclear fusion? Means hydrogen getting converted into helium. Hydrogen getting converted into helium. That is nuclear fusion. When this is doing, lots of energy is getting released. This is the giving life on earth for us, in fact. So star appear, they are twinkling. Okay, They are bright, they release light, energy. Life cycle of star is very important. So there is first nebula will be formed. Nebula means cloud of dust. Nebula, cloud of dust plus gas, you can say. Dust plus gas. From here, star is born. Okay. That star we call main sequence star. Main sequence star. Whatever we see, for example, sun is the main sequence star. Okay, main sequence star. Actually, in this dust, what will happen? These particles, whatever atoms or dust, whatever that one, these keep on colliding each other. So there will be always the friction. There is a friction. Because of this friction, heat will come. Because of this heat, they keep on generating a lot of heat in between. So they try to make some kind of proto star, we say. It is proto means a false star, means not really the star. So they try to condense, okay, little bit you can say condense into type of a star, not exactly star. It is proto star. After that, further when uh, nuclear fusion is completely taken over, then it becomes the main sequence star. This main sequence star again 90% of the star life, for example, if 100 years is the life cycle of the star, life of the star, 90 years will be as a main sequence star. It will spend. So after this main sequence star, its mass will decide it's the fate of that. For example, if mass is less than 1.44, this is what we call Chandrasekhar limit. This is what we call 1.44 wala. That is Chandrasekhar limit. What is this means? If less than 1.44 times the mass of the sun, then this star will become the red giant. Red giant means here no nuclear fuel is there now. So that hydrogen conversion of helium, that is not there now. Now nuclear fuel is over. Only stars will have that nuclear fuel, and nuclear fusion reaction is going on and lots of energy is getting released. But in red giant, there is no such reaction. After red giant we get planetary nebula. Planetary nebula. From here what happens? In this, all outer shells of the star will be keep going up, going off. So then finally, very core part of the star will remain. That is what we call white dwarf. White dwarf. Now after white dwarf, there is this is hot and dense. This hot and dense. Okay, very high temperature. Okay, low luminosity will be there. Means low lighting will be there because nuclear fission all it's gone. But it is very hot and very high density is still high, and temperature will be very very high, though lighting is very less. There is black dwarf, which is after cooling. Once the white dwarf cools, it will become the black dwarf. This is only theoretical black dwarf, because our universe is not that aged to give us a black dwarf. So there is a nebula, there is continuous friction, continuous heating, nuclear fusion will start, then main sequence star will come. After that, low mass stars, that is less than 1.44 solar masses. Solar means sun mass. 1.44 solar masses. Less than 1.44 solar masses. You get red giant, then planetary nebula, then white dwarf, then black dwarf. If it is greater than 1.44 mass, greater than 1.44, then you will get red supergiant. Red supergiant. After this 1.44 to 3 solar masses, you will get here actually after red giant there is supernova explosion. Supernova explosion means the star just explodes. 1.44 to 3 means you will get a neutron star. Greater than 3 solar mass means you will get a black hole. Black hole is something in the universe. Nothing can escape. Even if you send the light, even light cannot escape. Black hole will attract everything, including the light. That is the life cycle. I told low mass stars. For example, Sun is our low mass star. You get 1.44 times mass. Then red giant, planetary nebula, white dwarf, black dwarf. Then if it is massive stars like 1.44 44 to 3 times, then red supergiant, supernova, neutron star. If greater than 3 means you will get a black hole. Then star color and temperature are related. Color of a star indicates the temperature. The hotter the star, bluer it looks. For example, if you take blue, greater than 30K this is the symbol given O. So very massive star. 60 solar masses. 60 solar masses. Massive star. If it is redder, it is actually red means we will think hotter. No. Red means it is actually cold somewhat. Okay. Less than 35K. It is very small, low mass star. Hotter star, blue color. Cooler star, red color. Here it is given. Red dwarfs are the smallest main sequence star. Smallest main sequence star. They are the coolest. They make 75% of the Milky Way galaxy. They ask question, Milky Way galaxy, which stars are more? Red red dwarf. Then proton-proton chain reaction. It is nothing but nuclear fusion reaction, but it is like our sun, low mass stars. That is, there is CNO cycle, carbon, nitrogen, oxygen cycle. That is massive stars. So proton-proton chain reaction. Low mass stars like our sun, low mass, not very big. There is carbon, nitrogen, oxygen. This is also nuclear fusion reaction only. But here also nuclear fusion means I already told hydrogen is converted into helium. This is carbon, nitrogen, oxygen cycle is dominant in stars more massive than sun. Bigger sized stars. That is CNO cycle. Proton-proton chain reaction. Nuclear fusion only. Low mass star. Carbon, nitrogen, oxygen cycle. Nuclear fusion only. High mass star. Massive stars. Then light year. This is the distance between stars. How you will measure distance between stars? In light years. Light year. Within 1 year, how much the light will travel? That is light year. It is 9.46 trillion kilometers. And another unit also there, parsec. This is also we will measure distance between stars. It is 3.26 light years. And there is one more unit, astronomical unit. This is also within our solar system we use astronomical unit. For example, between Earth and Sun there is 150 million kilometer distance between Earth and Sun. This 150 million kilometer is equal to 1 AU, 1 astronomical unit. This Zeeman effect you remember, rotation of the star. Then Hertzsprung-Russell diagram. It shows relations between star temperature and its luminosity. Star temperature and its luminosity. It is related to star that you remember. Michelson stellar interferometer. You have to remember interferometer. Measure diameter of stars. Last stage in life cycle I already told white dwarf will be there. Lower mass. Neutron star, black hole for massive stars. Here white dwarf is a fossil star. They are hot, dense, I told. Low luminosity, but very, very high temperature. When it cools, it is called black dwarf. White dwarfs are smaller than Earth. First white dwarf discovered is Sirius B by Alvan Clark. Sirius B is the closest known white dwarf. Closest white known dwarf. Classification of stars based on the apparent brightness is given by Hipparchus. Hipparchus. He given 1 to 6. Brightest star 1 and decrease the brightness towards 6. Then Betelgeuse is a red supergiant star. Red supergiant I told. When there is nebula, then protostar, then main sequence star. Main sequence star. From main sequence star, you will get 2. Less than 1.44 red giant. Greater than 1.44, you get a red supergiant. Red supergiant. It is there in constellation Orion. Betelgeuse, constellation Orion. That is star you remember. Then oldest known star is Methuselah star. HD 14283. Then star catalog is given by Aristillus. Aristillus star catalog. Then Hipparchus later given Ptolemy. Then Ulugh Which of the following person given first attempt to give star catalog? Aristillus. If Aristillus not in option, Hipparchus you can give. Otherwise Ptolemy, Ulugh also. Now come to our star, that is Sun. His Sun is a yellow dwarf star. Yellow dwarf main sequence star. Yellow dwarf main sequence star. It is G type. No need to remember. It is predicted. I told main sequence star 90% life is as main sequence star, and then even star also it will vanish. It will go for some more billion more years. Star can live for billions years, but this live can be shorter or longer. This live can be shorter or longer. The bigger the star, the shorter is its life. Because if you take big star, it need more fuel. So it will consume more fuel and it will end faster. It will end faster. We know sun is there, 8 planets. Okay, their moons, many small objects like asteroid, comets. All together we call solar system. Solar system age 4.6 billion years. Universe age 13.7 billion years. Solar system 4.6 billion years. Even Earth also 4.6 you can say. Diameter of sun 14 lakh kilometer. Diameter of sun 14 lakh kilometer. And we know sun is largest and heaviest. I told 99.86% mass in our solar system is by sun. 99.86%. And all energy we are getting from the sun. All energy we are getting from the sun. How much time sunlight will take to reach Earth? 8 minutes. 8 minutes. And the sun is 109 times bigger. Sun is 109 times bigger. 99.86 mass. 330 kilometer times heavier than Earth. He is our nearest star. Sun is our nearest star. After Sun, which is another nearest, Proxima Centauri. Proxima Centauri. It is 4.24 light years away. Proxima Centauri. Proxima means having proximity, less distance. Sun is our center of the solar system, made of gases. It has a force. Okay. Sun will have gravitational force towards it. And as it is rotating, it will have outward force also. The sun is ultimate source of heat and light, we know. Nearest star. 150 million kilometer from the Earth. 150 million kilometer. We call it one astronomical unit. 1 AU. One astronomical unit. 1 AU. I told Proxima Centauri star. It is nearest star to the Earth. 4.24 light years. If we want AU, 269,000 AU. 269,000 AU. Proxima Centauri. Proxima Centauri. There is one more Alpha Centauri which is 4.367 light years. And Sirius, I told it is in Canis Major, dog star constellation Sirius. It is the brightest star in the sky. Brightest star. Which of the following is the brightest star? Sirius. Which of the following is the brightest star? Sirius. If you take our solar system, Sun is the brightest. Sun is the brightest. Next, you go for layers of the sun. There is 1 minute. If you take sun, there is internal thing where there is core actually. Then there is radiative zone. There is core, radiative zone. Then there is convective zone. So core is the place where nuclear fusion is happening. Nuclear fusion, where hydrogen getting converted to helium. At core. So there is core. This is the internal structure. If you take Earth, we have internal structure, Earth, and then atmosphere will have. Similarly to Sun also. There is core where nuclear reaction is happening. Hydrogen getting converted into helium, releasing lots of energy. And radiative zone, that energy getting radiated in radiative zone. Then convective zone. This is the outermost internal structure layer. These three layers you remember. Then atmosphere of the sun. Then in atmosphere we have again photosphere. This is what we are seeing. It is the visible surface of the sun. When we see outside, that is what we are seeing is actually photosphere. That is photosphere. Photo means light. Then chromosphere is there. After photosphere, there is chromosphere. This is the reddish layer of the sun. Is called a chromosphere. Reddish layer of the sun. Chromosphere. Here one remember solar prominence is dense cloud of some gas, ionized gas, is going sun's chromosphere into the corona. That is solar prominence. Actually, we have photosphere, we have core, radiative zone, then convective zone. Then here also we have atmosphere. There is photosphere, chromosphere. There is corona. There is here transition zone also there. Teacher, you can see. So from chromosphere to corona, there is some solar winds. You can see some gas is connected. That is what is called solar prominence. Solar prominence. That is transition region also that separate the corona from the chromosphere. And there is corona. This is outermost layer or outermost atmosphere. If you say Earth atmosphere, exosphere is the outermost atmospheric layer. Similarly, here corona is there. Extends millions of kilometers into the space. Corona is visible only during eclipse. There should be full eclipse. Then only you can see the corona. Because what we are seeing generally is the photosphere, not the corona. But if you want to see the corona, there should be eclipse. So you remember core zone, then radiative zone, convective zone. This is internal structure. Then photosphere, what we are seeing. photosphere, then chromosphere, this reddish layer of the sun, atmospheric layer of the sun. Then transition zone is there, and then corona, very important. For example, if you take Aditya L1 mission, this is to study the corona. There is also one peculiar thing is happening in the sun atmosphere. If you take here photosphere 5000 degrees, 6000, 20, and 1 million, you see. Temperature continuously increasing. Actually, from hot object, if you move away, temperature should decrease. But here temperature is very, very highly increasing. So to study this anomaly, only we're studying the sun layers. And then heliosphere, we know. Heliosphere means sphere where sun is having the influence up to that. Heliopause means you can say outer edge of the sun. Then Voyager 1 and 2 spacecraft sent to study this heliopause and interstellar space. Inter means between, stellar means stars, between stars. For example, here this is sun, this is his sphere. There may be some other sun also, no. There are also some. This is interstellar space. This gap. Then mass of sun 270 lakh moons. Mass of sun 270 lakh moons. Mass, if you combine that, then you will get mass of sun. If you take Earth 333,000, 1.98 into 10 power 30. Approximately 1.3 million Earths you can fit inside the sun. You can fit inside the sun. There is Oort cloud also. This is after Neptune. After Neptune, there is Kuiper belt. This is sun. We have Mercury. We have Venus. We have Earth. We have Mars. Then Jupiter, Saturn, Uranus, Neptune. After Neptune, there is Kuiper belt. There is Kuiper belt. Then after Kuiper belt, there is Oort cloud. There is Oort cloud. This is the outermost edge, you can say. Oort cloud. Heliosphere. What is heliosphere? It's like bubble region, or you can say till what extent the sun is having the influence. It is having sending the solar winds, it's a radiation, everything. Then Orion Arm. Orion Arm is the Milky Way galaxy. Solar system is located in that. Orion arm of Milky Way galaxy, where our solar system is located. Then stellar parallax, the apparent shift in the position of the nearby star. That is stellar parallax. Parallel means similar. Then nova hypothesis. I told supernova. It is nova hypothesis, so supernova explosion only. This theory is proposed by the Fred Hoyle and Littleton. Fred Hoyle and Littleton. Fred Hoyle and Littleton. Then nebular cloud hypothesis. I told already Laplace has given this nebular hypothesis. And before that, Kant, Immanuel Kant also given some theories. And one more person you remember, Carl von Weizsäcker. So famous person is Laplace. Nebular hypothesis. Cloud means same only. Nebular cloud hypothesis or nebular hypothesis given by Laplace. The sun does not rotate as a solid object. It exhibits differential rotation. That means at different latitudes, it will rotate different speeds. So average speed, remember, 21 days, one rotation it will take. 21 days for sun. Earth will take 24 hours. Earth will take 24 hours. Exactly 23 hours, 56 minutes, 4 seconds. Earth rotation. Planets or celestial, next we see planets or celestial bodies. They do not have their own heat. Very important point. Where sun is having nuclear energy, fusion, and he is giving energy, he is giving light also. But we don't have, our planets not have any source of light. They do not emit any light also. They are lit by the stars. Stars will reflect the from stars we get light. So planet means wanderers. That is the meaning. That is why planets are keep wandering now. Keep revolution they are doing. Nearly spherical object. Our Earth is a planet revolves around the sun. Planet is a large, nearly spherical object that revolves around the sun. Our Earth is a planet as it revolves around the sun. All eight planets of the solar system move around the sun in fixed path. Fixed path. Path is fixed. It is not Mars and Venus exchanging their paths. No. In elongated means that is elliptical. We say that is orbit. We say okay. Elongated orbit means elliptical orbit. Elliptical orbit. There are two types of planets: inner planets, outer planets. In, for example, first four: Mercury, Venus, Earth, Mars. These are called inner planets or terrestrial planets. Means they have rocky surfaces. For example, we take Earth, we have rock surface. Like that way, they have rocky surface. Whereas if you take last four, Jason, Jupiter, Saturn, Uranus, Neptune, they have icy gases, gas plus ice. You can say they have rocky surface. Of course, in between there is asteroid belt. Asteroid belt. These are remnants of planets. Means maybe while forming the solar system, there are some irregular shaped rocky planets. You can say, or kind of minor rock fragments. You can say they remained. They could not become the planet. They are called asteroids, and the belt these asteroids more or you can find in AB between Mars and Jupiter. This is important question. Between Mars and Jupiter, that is asteroid belt. These are called asteroids are called minor planets. Minor planets. They are called minor planets. They are also called planetoids. Toid means like planets. Planetoids. They revolve around Sun only because they are located between Mars and Jupiter. They revolve around Sun. There are various size is there. Okay, meters to kilometers. Various size is there. So if you take these are inner planets, these are outer planets. These are terrestrial. These are gaseous, rocky. Icy planets. Gaseous, icy. These will not have any rings, and these will have rings. For example, if you take Saturn, it will have rings, very beautiful rings. Will Saturn will have the same points mentioned here. You can see it here. Uh, it is near to sun, far from sun. Solid surfaces with rocks on them. These are gases, ice, mostly made up of gases. Hydrogen, helium, like that gases. Then gas giants, Jupiter, Saturn, mostly hydrogen, helium. Lighter gases filled. Gas giants, Jupiter, Saturn. Ice giants, Uranus, Neptune. Because they are far away, means there will be ice. They are far away. Sunlight will be they're receiving sunlight very less. So you can find ice. So ice giants we call Uranus and Neptune. You can find methane presence in Uranus and Neptune. Methane presence, Uranus and Neptune. Smaller in size, this, and these are larger in size. For example, if you take size, Jupiter is the largest. Okay, this is the order you remember. Jupiter, Jason you remember. Jupiter, Saturn, Uranus, Neptune. This is the order. Then Earth, then Venus, then Mars, then Mercury. So Jupiter is the largest. Mercury is the smallest. So what is the largest planet? Jupiter. Smallest planet? Mercury. And these rings, it will have rings. Outer planets will have rings. This mainly compose the dust and icy material. Dust and icy material. I already told planets get most of their energy from the sun and all. If you see, farther they are, colder they are in general. The presence of atmosphere on a planet can trap heat. For example, if you see Mercury, it is not having any atmosphere, so it cannot trap heat. But if you take Venus, it can trap the heat. It can trap the all CO2 and all. So it is very hotter than the Mercury. So it is called hottest planet. So what is the hottest planet? Venus. Why hottest planet Venus? Because though Mercury is closer to Sun, it is not having any surface, sorry, atmosphere. So it cannot trap heat. The heat will go away. But if you see Venus, it is having CO2. There is atmosphere, and in atmosphere you can find CO2. So that's why it is the hottest planet, Venus. Though Mercury is the closest to the Sun. Though Mercury is the closest to the Sun. Solar system 5 officially recognized dwarf planets, remember. Pluto we know, then Ceres, Haumea, Makemake and Eris. Ceres is located in asteroid belt. Ceres is located in asteroid belt, whereas others are uh, after in Kuiper belt. Other four are in Kuiper belt. Other four are in Kuiper belt. So Ceres is located in asteroid belt, and the others are located in Kuiper belt. I told after Neptune, Kuiper belt will come. After Kuiper belt, Oort cloud will come. Then superior planets, inferior planets. It is very easy. Before Earth, these are inferior planets. After Earth, these are superior planets. Next, dwarf planet word is coined by Alan Stern. Next, Mercury, it is nearest to Sun. I told closest to the Sun. Takes about 88 days to complete one round along its orbit. For example, this is Sun. It will take 88 days to complete the one round. Means one revolution. Means 88 days is 1 year there. Earth take 365 days. Means 1 year for us. But 88 days only it will take. Mercury, the smallest planet, while Jupiter is the largest. BP Colombo, you remember, this is the mission for Mercury. And there is another mission, Messenger. This is also to study Mercury. Then Venus, very, very important. Venus, it is called Earth's twin. Why we call Earth's twin? Because of its size, shape is similar to Earth. That's why Earth's twin. Nearest planet to the Earth, not to the Sun. To the Sun, Mercury. Here Mercury is there. Here Venus is there. Here Earth is there. This is Venus is there. Mars is somewhat far away. So nearest means Venus. Nearest means Venus. So second nearest Mars. Then Mercury will come. So Venus is also called veiled planet. Veiled means it is covered with something. Because it is covered with CO2 and thick clouds of sulfuric acid. There is thermal runaway effect is there. Venus is called morning star, evening star, because at dawn and dusk it will glow very high light it will give. Even though it is not a star, it is called morning star, evening star. That is Venus. It is brightest planet. Brightest planet. Sun, after the sun, then second moon, third Venus. Venus is the brightest. Then fourth brightest is Jupiter. So brightest planet will ask Venus. Brightest sun is the brightest. Then second brightest is moon in our solar system. And Venus we know UV, remember UV. Venus and Uranus. Okay, all going west to east you can say, or clockwise you can say, like this, clockwise. But these are anti-clockwise you can say, not in clockwise. Uh, no, rotation actually. Rotation, if you take Earth, these are west to east, we are going west to east. But this is reverse, east to west. east to west. Then hottest planet I told. The Venus is the only planet where sidereal day is longer than solar day due to its slow and retrograde rotation. We say retrograde. It is not west to east but opposite to that. Then Venus is the planet that show phases. Phases means sometimes it will bright like that. Brightness will keep on changing and like that. For example, if you take moon, there is new moon, then full moon, like that. Then half moon in between. This is phases. Like that, Venus will have also having the phases. It will also show phases. Then not a flattened like other planets, their poles. For example, if you take there is a flat Earth, there is flat here, and there is bulge here, Earth. But Venus no such flattened thing on the Venus. Then Magellan spacecraft 1991 to study the Venus. Then a rotation is longer than revolution. For example, rotation it will take 243 days. 243 days, and this is some around 223 something, 220 something. Then Earth we know third nearest planet to Sun, fifth largest planet. Okay, Jupiter, Saturn, Uranus, Neptune. Then Earth will come. So fifth largest. This shape is called a geoid. Earth is in Goldilocks zone, means not too hot, not too cold. So there is presence of water. For example, you take outer planets; they are very far away, so you cannot find water. You can find water in ice form, not in liquid form. You take Venus or Mercury, you can find in water vapor form. It is not in liquid. So Goldilocks zone means it is habitable zone. Earth is called blue planet. Why? Two-thirds is the water. Light speed, remember, 3 lakh kilometer, and 8 minutes will take sunlight to reach the earth. Rotation time 24 hours exactly means 23 hours 56 minutes 4 seconds. Revolution 1 year exactly means 365 days 5 hours 48 minutes. Several names you remember: Gaia, Terra. Terra means earth, we know, clay like that. And Tellus, globe and world, we know. 4.6 age. Earth's historical time scale, you remember, there is eons, which is largest geological time stream, then era, then period, epoch and ages. Then eons are further divided: Hadean, Archean, Proterozoic, and Phanerozoic. The first three are called Precambrian, this Hadean, these three, not required. Four eons. First one you remember: Hadean, Archean, Proterozoic, Phanerozoic. So that is Earth. Remember shape geoid. Goldilocks zone important. Blue planet important. 8 minutes time. Rotation revolution time. Rotation 24 hours. Exactly means 23 hours 56 minutes 4 seconds. Revolution 1 year. Or 365 days 5 hours 48 minutes. Various names: Gaia, Terra, Tellus. 4.6 billion age. Geological times, highest times, eon, EON, eon. Then you come to Mars. Mars is called red planet. Very important bit. Why it is called red planet? Its rocks on every having rust. That is iron oxide because of rust. It has two moons, Phobos and Deimos. Okay, Mercury will have zero moons. Venus will have zero moons. Earth will have one moon. Mars will have two moons. Phobos and Deimos. Phobos and Deimos. And ice caps north and south poles. So there is small amounts of water. There is possible dried up river beds, etc. Have been found. So there is in previously there is some rivers might have been flown. Also north south pole you can find some what ice. Babylonians called it as Nergal. Mars is called Nergal. Romans called Mars. Romans M is there, so Mars like that. Most abundant gas in the atmosphere of Mars. Very important. Carbon dioxide. How much it is? 95.32. 95.32. 95.32. Then Curiosity rover has been sent to study Mars by NASA. That has been found. CO2 is there, 95.32. This is gas distribution. Carbon dioxide, 95.32. Second, nitrogen. Third, argon. Then we can one to send to study Mars. India also has sent Mars orbiter mission. Then highest volcano in the solar system, Olympus Mons. What is the height? 22 kilometer, around 20. Around 20. It is having the caldera also, which is 85 kilometer wide. If you take width 700 kilometer is the width. Means across means it is spread. Height. So this is 700 kilo across means. Height means 22. There is caldera also of 85 kilometer. Means if you take this is volcano. There is caldera means some vent here. Okay, some vent has come out and some depth is depression is happened. That is caldera. And Mars day length and axial tilt are same to similar to the Earth. It is called dusty planet. Okay, dusty planet. It is called dusty planet. Then Amazonian period. For example, eons we call for Earth. Earth geological time. Similar time period is Amazonian for Mars. And Jupiter, Jupiter largest one. Jupiter is the largest and it will have rings. Jupiter, Saturn, Uranus, Neptune all have rings, but more prominent is Jupiter. Sorry, Saturn. Saturn will have more prominent rings. Saturn will have more prominent rings. Jupiter is the largest planet. It is called winter planet because very low temperature you can see. Ganymede, largest satellite in the solar system. It is called bright wandering star. It is called bright wandering star. Maximum weight on Jupiter. What is the weight on Moon? 1/6. On Moon, 1/6. Fastest rotation. So shortest day it will have. NASA Europa Clipper mission. There is Europa. This is the moon of the Jupiter. Jupiter moon. There it is believed there is some subsurface ocean. Means under Europa, under surface there is some ocean. So NASA Europa Clipper mission is NASA is trying. Quasi-quadrennial oscillation related to quadrennial oscillation. Quadrennial oscillation is related to Jupiter. That is eastward westward winds keep changing alternately. Comet Shoemaker-Levy 9 smashed Jupiter in 1994. There is great red spot, that is high pressure storm. High pressure means anticyclone. So there is low pressure means that is cyclone. High pressure means anticyclone, that is storm only. Anticyclonic storm. Great red spot Jupiter. There is white red spot. Sorry, white spot. Great white spot. That is in Saturn. That is in Saturn. That is in Saturn. Then Phaethon, Phaethon. Phaethon is often associated with Jupiter. Pioneer 10 is the first spacecraft that make close observations to the Jupiter. It just close observations. But which orbited first means Galileo spacecraft. Which space to orbit. To orbit means it going and orbiting the Jupiter. That is Galileo. Which make just some observation. Pioneer 10. Pioneer 10. Pioneer 10. Saturn. Second largest planet. Rings are there. Titan satellite Saturn is having. Saturn T is there. You remember? Titan. Second largest in the solar system. Discovered by Christian Huygens. Least dense planet. Which is densest? Earth is most densest. Earth is most dense planet. Earth is most dense planet. Saturn named after a Roman god of wealth and agriculture. The Saturn's largest moon, Titan, is having the atmosphere, substantial atmosphere. Only moon in our solar system known to have a substantial atmosphere is the Titan. Even moon not have atmosphere, no atmosphere. There is great white spot I told, periodic storms. Great red spot Jupiter, great white spot Saturn. There is Cassidy mission related to Saturn. Uranus, very very important, greenish color. Why? There is methane gas. William Herschel found it. William Herschel, first planet to discover through telescope. Some 13 rings are there, and equator is near. It is planet on its side. We call it is planet on its side. Actually, Earth, if you take 23 off, it is, but it is almost right angles. Planet on its side, almost by side it is rotating. Then Uranus, Neptune, these are called ice giants. Jupiter, Saturn, these are called gas giants. Jupiter, Saturn, these four are called outer planets or gas planets. Outer planets are gas planets. Then diamonds, rainfall will be there on these two, Uranus and Neptune. Why diamond? Here in both, methane is there. Methane means CH4. From carbon only we get diamond under high pressure temperature. Uranus having 28 known moons. These are important known moons. Miranda, Ariel, Umbriel, Titania, Oberon. These are called literary moons for the Uranus. Literary moons. Why Shakespeare used these names in his literature? Neptune. Uranus is similar to Neptune, so twin of Uranus. It is called twin of Uranus. Methane rings are there. Even Neptune also having rings. Five five main rings. These remember: Gelli, Leverrier, Lessel, Rago, Adams. 16 known moons. One moon you remember, Triton. Triton, Neptune, Triton, Neptune, Triton. There is Gelli, Leverrier, Lessel, Arago, Adam. These are all rings. These are all rings. But there are moons also. Triton moon, Triton, Triton. There is Voyager probes. Voyager 1, 2, 3 probe I told. Went up to interstellar space. Voyager 1, 2 by NASA. Voyager 1, 2 by NASA. And great dark spot. You see, it is away from sun. So great dark spotting. Like that you remember. Anticyclonic storm. Next, Pluto. Pluto was discovered in 1930 and it was a planet till 2006. But later on, International Astronomical Union in 2006, that is 24 August 2006, declared it is not really a planet. It is only a dwarf planet. It is only a dwarf planet. Why it declared dwarf planet? We will see. Reason is it is having no clear neighborhood. Some other rock fragments are revolving and influencing its orbit and all. And it is given 134, 340, the number. There are three conditions required to be qualified as a planet. A celestial body has to be in orbit of the sun. Like Earth, we are moving like that. It should be revolve around the sun. Also have sufficient mass, like round shape it will have to maintain hydrostatic. It should have round shape. Then it should have clear neighborhood. Here Pluto fails. Pluto qualified this one revolving around sun. It is having round shape, but this it is failed. So it is not a planet. It is only a dwarf planet. What is the number? 134, 340. What is the date? 24 August 2006. When it is discovered? 1930 by Clyde Tombaugh. Flight Tombo. Flight Tombo. It will come after Neptune. It will come after Neptune. Next, satellites. What is satellite? This is sun. These are stars. Sorry, planets. This is Earth. And if around planet there is some object rotating, sorry, revolving. This is what is called moon. So around planets, if anything is there, that is called moon. It can be natural also. It can be human made. For example, ISRO is making satellites. NASA is making satellites, communication satellites, everything. So some major moons in the solar system. Ganymede is the largest. Ganymede, Jupiter. Largest Titan, Saturn. That is second largest. Then Callisto, Jupiter. Low also Jupiter. Then Earth's moon is the fifth place. Earth's moon is the fifth place. Then sixth Europa. Then sixth Europa. Then moon, only natural satellite, only one quarter of the size of the Earth. That is 25% of the Earth. This diameter, circumference, everything I given elliptical orbit, apogee, perigee. Apogee means it is coming away, going away. Perigee means coming. Uh, peri means very near. Apo means away. Peri means near. Apo means away. For example, this is Earth. It's going elliptical orbit. For example, this is perigee. This is apogee. Apogee means it is somewhat away. Then rotation time you take 27 days. Rotation revolution same time. Then synodic month, sidereal month. These are important terms. Sidereal, synodic. We will discuss later. Only we will see 60% of the moon surface only visible because as Earth rotates, moon also rotating. So we can see only one side of the moon. There is sea of tranquility. Of course, this is the plain, not the sea. So it is 384,000 kilometer away. 384, 400 kilometer away. 384, 400 kilometer away. 27 days is the rotation revolution also. Not have condition favorable for life. It is having depressions because many impacts will be there. Many rocks, etc., will be falling from the space onto the moon surface. Full night we call Purnima, new moon we call Amavasya. I told full moon, new moon. There is phases of moon. There is phases actually. Neil Armstrong we know 21st July 1969, first fellow to uh, go to the moon. And we have Chandrayaan 1 launched in 2008. It found some water hydroxyl water molecules. OH. In Chandrayaan 2 19, it tried to soft land but failed. So again in Chandrayaan 3 we soft landed on the South Pole. On the South Pole. When? 23 August 23. That's why we celebrate it as a National Space Day. There is Apollo 11 mission. Sea of Tranquility is the place where it went. Apollo 11. Then Lebuty Mountain we having, and then no atmosphere, nothing. This is temperature 100 minus 180. 1.3 seconds to reach light from the moon to the earth. From 8 minutes to reach to the earth from sun. But it is 1.3 seconds to reach light from the moon. Selenology means study of moon. Selenology, study of moon. Moon is known as fossil planet. 2.38 km per second. 2.38 km per second is the escape velocity. Weight 1/6 I told. There is umbra means shadow of the moon. Penumbra means it is a outer shadow, like not dark shadow you can say. Sky appears black from the moon, whether it is day or night in the moon on the moon. Selene is the Greek goddess of the moon. Selenology I told you, study of moon. Selene is the Greek goddess. It is having names. Romans called it as Luna or Diana, also Roman goddess. Then in Greek they call Selene or Scythian. Then Valley of Taurus Litro. It is located where Apollo 11 landed, Sea of Tranquility or Sea of Serenity, near that place. Soviet Luna 3 went to far side of the moon. Rear side means far side. I told only we can see one side of the moon. This one. Okay. But Soviet Luna 3 went other side of the moon. That is rear side. Rear means back side. Far side of the moon. Then asteroids, I told. Asteroids are, there is Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Here asteroid belt is there. They revolve around Sun, correct. Between Mars and Jupiter, correct. There is belt is called asteroid belt. 10 meter to 500 kilometer. They are called minor planets, planetoids. Minor planets, planetoids revolve around Sun. But between Mars, Jupiter, this is debris failed to become planet. Asteroid belt. Trojan asteroid, remember, it is in the orbit of the Jupiter. Largest asteroid, Ceres. Ceres is also a dwarf planet. Ceres is also a dwarf planet. There are 5 dwarf planets: Pluto, Ceres, etc. First asteroid to be discovered. First asteroid to be discovered is the Ceres. First asteroid to be discovered. Then comet. Comet means there is one nucleus will be there. Okay. Then coma will be there. Coma means some gas, dust will be there. This is coma. Okay, this gas will. Whenever it is coming to near sun, okay, this will evaporate and it will form the tail. So this tail is always away from the sun because the sun's energy will push this. So the tail will be always away from the sun. So sometimes we have visitors from outer regions of the solar system. These objects are long tails called comets, made up of very, very important dust, gas, rocks, ice. As comet approaches close to the sun, the frozen material starts evaporating. This evaporating material forms the tail. Comets appear dim as they move away from the sun. Hence, it is not possible to see them with the naked eye. So, comets visible only when it travels close to the sun. Many comets have been found that revolve around the sun. These comets approach sun periodically. Few comets that escape and move out of the solar system also. Few other broken up. They fall towards Earth. That we call meteor shower also. Meteor shower. Very famous comet. Very famous comet is Halley's comet. It comes every 76 years. 1986 it came. You add plus 76, it will come next in length. So there is tail. So coma already told. So nucleus, coma, tail. Nucleus, coma, tail. So first comet observed by manned spacecraft was Comet Kohoutek. Comet Kohoutek in 1973. Comet tail always points away from the sun because sun's energy will push that. It will evaporate the other side. It is also called a dirty snowball. It is shaped like a long oval, means elliptical orbit, long oval like that. Several years to make one revolution. That meteor shower I told, burn up in the sky. And then nucleus. Then there is coma. Then tail. Fairly close to the sun. Then only you can observe the comet. The coma and tail lasts only while the comet is fairly close to the sun. Comet tail will be very long, as long as distance between Earth and Sun. So comet tail is very short. Wrong statement. Then meteoroid, meteor and meteorite. Meteorite means it is a space rock. Meteor means when it is coming to the mesosphere. So this is Earth. This is Earth. There is a mesosphere here, third layer. In mesosphere, these meteors will burn. We call that time it as a shooting star. Shooting star. So meteorite, a space rock. Meteor, when it is coming to mesosphere and burn, that is meteor. Some will reach the earth also. That is called meteorite. So meteorite, space rock. Meteor, mesosphere, this will go, vanish away. Some, when it reach earth, it is called meteorite. Some table is given. I told revolution of the Mercury is 88 days. 88 days. Shortest day I told. Shortest. Jupiter will rotate fast. So it is the shortest day. Jupiter will have Ganymede, largest in the solar system. And then other Europa, Lo, Callisto. These four, Ganymede, Europa, Lo, Callisto. These are called Galilean moons of the Jupiter. Galilean moons of the Jupiter. I know Saturn, Titan is the second largest moon in the solar system. Then Earth is the densest. Saturn is the lightest. Saturn is the lightest. Jupiter is the largest. Mercury is the smallest. These are standard beats. And Earth will take rotation 23 hours, 56 minutes, 4 seconds. And longest year are Neptune only because more it has to take big circle, you can say. Then rotation means the planet, it will rotate. Revolution means around something. Venus, Uranus, retrograde, the opposite, west to east, all other planets. But this is reverse. Jupiter shortest day, Venus longest day. Venus longest. Ganymede largest moon of the Jupiter. Largest, of course, overall also. Titan second largest moon or satellite. Pythagoras first person to say Earth was shaped like a globe. Then perihelion, aphelion. Perihelion, helion means sun. It is sun and earth. Because here, if you take this is sun, okay, here earth is there, okay. And this is what is aphelion. Apo means away. Peri means near. Perihelion. So perihelion will January 3rd, 147 distance. Aphelion farthest to sun, July 4th, 152.5. Average distance 150. Perihelion means it will come somewhat close, 147.5. That is January 3rd will occur, perihelion. Aphelion, July 4th, 152.5 million kilometer. Then solar eclipse, lunar eclipse. Solar eclipse, lunar eclipse. It's very easy. You take, this is sun. Okay. This is earth. Earth should be small. Okay, this is earth. Then here moon is also orbiting. Okay, this is moon. This is earth. This is moon. This is sun. So here shadow is falling. Means here sunlight is blocked by the earth. This is called lunar eclipse. Lunar eclipse. Lunar eclipse. Last moon. Moon will be lost. Last side. That is lunar eclipse. This will happen on the full moon phase. Which phase? Full moon phase. Full moon phase. That is lunar eclipse. You take sun, you take earth. Here moon is coming. Here moon is blocking the sunlight. Here moon is blocking the sunlight. This is called solar eclipse. This will happen on the new moon phase. So new moon phase, solar eclipse, full moon phase, lunar. So lunar U is there. Lunar full. You remember lunar full moon, and L last. L last. And types remember total solar eclipse, partial solar eclipse, annual solar eclipse. So total solar eclipse means it complete block. Partial means partially. Annular means, for example, this is, it is blocking only the this annular kind of thing. Means the outer ring you can see the from the earth. You can see outer ring, that is annular. Only ring we can see, and remaining all blank you can see. That is one. Lunar eclipse also same. Total means complete block. Partial means partially blocked. Penumbral means it will look dim. Blood moon refers to lunar eclipse. Okay, during total lunar eclipse, the moon will appear very red kind of thing, in very huge, bright red color. Bright red color. The table is given. Same what I explained. Solar eclipse, lunar eclipse. Solar eclipse is somewhat rare, and it is also can be seen from the very small place. Whereas lunar eclipse you can see from one half of the earth. Half of the earth people we can see the lunar eclipse. And lunar eclipse is more frequent compared to solar eclipse. That same explained here. Diamond ring effect I told. We can see only some ring of the sun when moon blocks it. Sometimes uh, it is having craters, moon, okay, so that it will look like some bright, like this bright color, like this, and this ring. So this is like diamond ring it will. So that occurs when during total solar eclipse. Then Galilean moons I told, Lu, Europa, Ganymede, Callisto, all are Jupiter moons. Ganymede is the largest. And Galileo is called father of observational astronomy because he observing the moons of the Jupiter I told, phases of Venus, analyzing sunspot, and Saturn rings also discovered by Galileo. Saturn rings, bright rings, Saturn rings. The first planet to have its motions plotted across the sky is the Venus, the two in second BCE. Then heliocentric model first proposed by Aristarchus of Samos. Then who actually very famously proposed Copernicus. Then geocentric model by Ptolemy, laws of planetary motion by Kepler. There are three laws how planets orbit the sun. There are three laws are given. Law of ellipse, law of area, and law of periods. No need to go deep into that. Then Hubble constant, you remember? This is the expansion rate. I told Hubble he given redshift. What is redshift? Stars are moving away from us, galaxies are moving away from us, and plus among each other also they moving away. That is redshift movement, moving away from each other or from our from us also. That is universe is expanding. Universe is expanding. That is what is happening after the Big Bang. That Hubble constant, you remember? Okay. Earlier NASA told 74. Now recent report they saying around 70. So around 70, 72, 73. That is figure you remember. Then sidereal day, solar day. Sidereal day you simply see. You take uh, Earth and you take you rotation with respect to the another star, other stars, distant stars. Is that is what sidereal day. It will take 24 hours. 23 hours 56 minutes 4 seconds. That is sidereal day. Solar day means you take sun. Okay, sun now noon. Up to next noon, what is the time? That is solar day. That is sidereal day, solar day. Solar day is more because sun is doing rotation also. So to cover that time, solar day is actually more. So that's why solar day is greater than sidereal day. Solar day is so actually 24 hours is the solar day. But sidereal day 23 hours 56 minutes 4 seconds. So 3 some 56 if you say 4 minutes approximately. Solar day is more. Similarly, month means it is related to moon. Sidereal month, same moon rotation. Synodic month with respect to uh, moon from one point to another point. Then Lagrangian points are there, some stable points of the triple system. Okay, Sun, Earth, Moon. L1, L2, L3. For example, L1 is sent Aditya mission. Then nova, supernova, I told explosion in stars. Hypernova also same. This nova, small mass stars, low mass stars. Supernova, hypernova, high mass stars. Kilonova is when neutron stars are matched. Neutron plus neutron or neutron plus black hole. Neutron stars. Neutron stars I told during life cycle of star. This is what I explained here. Then triple alpha process. Triple alpha process, what is this? 3 helium converted into carbon nucleus. When star is exhausted its core hydrogen fuel, it doing this immediate reaction. That is triple alpha process. When star is having nuclear fuel, that is doing proton-proton chain reaction or CNO cycle. When nuclear fuel over, then it is doing triple alpha process. Triple alpha process. Then pulsar is nothing but there is neutron star. It releasing some pulses of light. Okay, light. For example, like this, some pulses of light is releasing continuously. It is lighthouse. That is what pulsar. Okay, it is having lighthouse effect. Which of the following is pulsar? Then Bell discovered the first pulsar. Then evolution theories, remember only very few. Nebular hypothesis, Kant Laplace, planetesimal, Chamberlain, Moulton, tidal hypothesis, Jeans Jeffrey, binary star hypothesis, Littleton. I think Fred Hoyle also there. Then supernova hypothesis, Fred Hoyle, Littleton is there, and Sacker and Cooper. These are at least important. How solar system and how Earth evolution has done. Then Immanuel Kant or Kant Laplace hypo. Nebular hypothesis I already told. Laplace is the most important. Binary star hypothesis. Russell Littleton also remember. Then Cepheid hypothesis. Cepheid means variable star. It is proposed by A.C. Banerjee. Cepheid hypothesis proposed by A.C. Banerjee. Then Nova hypothesis. In table it is given Cooper and Fred Hoyle Littleton. Nova hypothesis. Next, origin of moon. Fission hypothesis. Georges Darwin. Then double planet theory or accretion theory. Double planet theory or accretion theory is related to origin of the moon. Then some other theories. You remember theory belongs to which thing, that's all. Fission theory, you remember name. Next, capture theory. Next, accretion theory. Giant impact hypothesis. Giant impact means a Mars-sized body called Theia. A Mars-sized body called Theia hit the Earth. Then from Earth some part is formed as a moon. These are main. Fission, capture, accretion, giant impact theory. Giant impact theory related to origin of Mars-sized body named Theia hit the Earth. Then this giant impact theory, Rob D. Major is related to that. Then lunar phase, I know I told 8 lunar phase are there. First new moon, waxing crescent, then first quarter, waxing gibbous, then full moon. Then again it will waning. Waning means decreasing. Waxing means increasing. Waning means decreasing. Waning gibbous, third quarter, waning crescent. Once a month it will repeat, approximately 29.5 days. Moon surface have to mountain huge craters are there. Okay. Flat plains are called seas. Seas means don't think that it is a sea, actual sea. No. It is hot and flat lava. Astronomy means study of objects, celestial and astronomical phenomena. So this is somewhat good content, if you feel it is fast, you just listen again and try to get all the facts. You solve PYQ in exam. These facts will suffice for an exam.